works today. Okay.
All right, so we did the other two probability trees last class. And so we're just gonna finish up with this last one. I think probability trees are one of the easiest ones. Sometimes it's just about knowing when to do it. I use probability trees when it's like something yes or no, and then from that, it's another circumstance or another situation, yes or no. So in the first one, it was about it raining, yes or no rain, and then doing homework, yes or no homework. Same thing on the last one we did, yes or no soccer, yes or no lacrosse. This one is about noodles and salad. It says if the cafeteria serves noodles, then there's an 80% chance they'll serve salad. If they don't serve noodles, there's just a 50% chance they'll serve salad. Given they serve noodles just once each school week, find the probability that they will serve salad. Okay. Since this last sentence says, given that they serve noodles just once each school week, that means noodles is like my independent thing that everything else depends on. So we're gonna write noodles first. So we'll say noodles. And then we'll say no noodles. And then from that, we can have salad, or we could have no salad for both of those options. All right, now it's up to us to figure out what our percentages are. The very first sentence of the whole problem said, if they serve noodles, then there's an 80% chance they'll serve salad. So that means I go up, follow my path through noodles, and then go to salad, and that's 0.8. So then what's the probability we will have noodles but no salad? 0.2, very good. Similarly, my next line says if they don't serve noodles, there's just a 50% chance they'll serve salad. So we're gonna say 0.5 for yes salad, and how much for no salad? Also 0.5, good. Now, the noodles or no noodles is where the probability gets a little interesting. It's not too hard, but it's a little bit different. It says, given they serve noodles just once a school week. Okay, they do it one time, and how many school days are there in a week? 5. So we're gonna say 1 out of 5 chance that we're gonna get noodles. So 1 divided by 5 is about a 0.2%, or 0.2, 20%. So yes noodles is 20, which makes no noodles 80.8, all that stuff. Everyone okay with building my probability tree? Now we just follow the lines, and we're going to end up with salad each time. So we'll say yes noodles and yes salad. So I'm going to say 0.2 times 0.8. And then we'll also say plus, because we're okay with another situation, which is no noodles, but yes salad. So 0.8 times 0.5. Right, multiply them together. 0.2 times 0.8. 0.8 times 0.5 and 0.4. Add them together, and I get 0.56, which is 56%. Okay. We feel okay about that? Probability tree should be a nice little easy part. Now, we are not going to do this right now. If I decide later to come back to it, I will, but this is definitely not on your quiz, so I'm not worrying about it right now. The rest of your 9.3 should be done. Everything else should be done. However, there's one part of 9.2 that I skipped that I want to come back to. So I want to do number 4 today. Now, this problem that I'm doing right now, I will not put something like this on your quiz tomorrow, but it is fair game for your test in a week or so. What is fair game for your quiz is problems like 2 and 3, where we had to expand something out or find the something term. This was our binomial expansion. So if you remember, we used our Pascal's triangle. That gave us the coefficient. And then we reminded ourselves that our variables, the x's went downwards as you went across the page, and the y's went upwards as we went across the page. So I started with x to the fifth, and then I went down x to the fourth, x to the third, x to the second, x to the first. And then my y started at 0, y to the 0, then they went up as we went across the page. You guys kind of remember doing this? I will tell you this is probably on your quiz tomorrow. Okay, now that being said, we are going to use binomial expansion here for this problem, okay? The reason this is different than just a normal, like, oh, roll the dice, what's the chances or what's the probability of getting something, is that we're going to roll the dice 5 times and we want something specific to happen or to not happen. Okay, so we're going to think of this as like, we have a binomial expansion, x plus y to the fifth. The exponent is how many times you're doing it. Number of times. So in this case, I'm rolling a dice 5 times. If it said we're flipping a coin 3 times, or we're doing something 7 times, that's going to be my exponent. And then our x and our y go with your yes and your no's. For sake of what I wrote in my notes, we'll do this. We'll say x is our no, and we'll say y is our yes. Yes, something happens versus no, something doesn't. For example, we're going to kind of think about the first one as I kind of give you a framework that we're going to use for the rest of all of these problems, okay? The first example says we want to find the probability of rolling a dice 5 times and getting exactly 1 3, okay? There are a bunch of different things that can happen, okay? The very first time we roll the dice 5 times, you could get 0 3s, so 0 what we want. I'm going to say 0 yes, 0 yeses, and we could get 5 no's. Okay, so I could roll that dice 5 times and I could get no 3s and all like 1, 2s, 4s, 5s, and 6s, right? That could happen, right? Another thing that could happen is I could roll and I could get 1 3 and I could get 4 not 3s. Are you guys following along with the situations that I'm thinking of right now? So then the next chance would be maybe I get 2 3s and 3 not 3s. Then I could get 3 3s and 2 not 3s. And then there's 2 more things that could happen. I could get 4 3s and 1 not 3, or I could get 5 3s and 0 not 3s. Okay. All right, you okay with all of those options? Okay, this is basically our binomial expansion. So if you think about what we had above, my x is my node. That means that my x is going down as we go across this page. It's like x to the fifth, and then y to the, or x to the fourth, and then x to the third, and then x to the second. You guys kind of see that? Same thing with my y. The first one is like y to the 0, but then it goes y to the first, and then it would be y to the second. If you remember when we did our binomial expansion, it's not just these. We had coefficients that came from my Pascal's triangle. So we have to use our Pascal's triangle. We have to use our coefficients. And I circled that last row because that's the row we would have used, something to the 5th power. In all of these cases, I'm going to have a coefficient or something I'm multiplying by 1, 5, 5, oh no, 1, 5, 10, 10, 5, 1. Now I've done this enough. I just know that's the bottom line of your Pascal's triangle, but you can go back up to your Pascal's triangle. And we're just copying that bottom row to be multiplied here with all of our probabilities. Okay. Now, I know we use the example of 3 this whole time, but all of these are kind of getting or not getting something specific. So we're going to use this idea as we write down and figure out what our probabilities each time is. Okay. So my first thing is, it says getting exactly 1 3. That means I'm only getting one thing that I want, right? That means I'm looking at this spot right here. Oh, I did not mean for that to be quick there. That's okay. I'm looking at this spot right here. Okay. I'm going to think of it as 5, because that's my binomial, coefficient, that's my expansion part, that's my Pascal's triangle. I'm gonna do 1y to the first, which means the probability of getting what I want to the first power. If I just rolled the dice one time, what's the probability of getting a 3? If I just roll it one time, what's the probability of getting a 3? 1 out of 6, very good. So my first thing is gonna be 1 out of 6. I only want that to happen exactly one time, so I'm gonna say that's being raised to the first power. That means my other 4 times need to be one of the other numbers besides 3, and what's the probability of rolling not a 3? 5 out of 6, so I'm gonna say 5 out of 6 to the 4th power. Okay. All right, now we're gonna throw that in the calculator and multiply it out. So 5 times 1 divided by 6, and then times 5 divided by 6, caret, or raised to the 4th. And that is about 40%. You guys okay with that? It's not too crazy. Okay, we're doing a very similar thing for the next one. It says, now we want to get 0, 2. We want to get no 2s. That means instead of looking at the situation where I got 1 yes, I want to look at where I get no yeses. So which one is that? It's the first one, right? I have 0 yeses right here in this first one. So that means I'm going to do 1 times the probability of getting a 2 is what? 1 out of 6. And how many times do I want to get that? 0 times. So I'm going to raise that to the 0 power. What's the probability of rolling anything else besides the 2? 5 out of 6. And how many times do I want that to happen? 5. So I'm going to raise that to the 5th power. Now, what is anything to the 0 power? Just 1. So basically, this is 1 times 1 times 5 over 6 to the 5th. So that's all I'm going to put in the calculator. I'm just going to put 5 over 6 to the 5th in the calculator. 5 divided by 6, caret 5. And that is also about 40%. You guys hanging with me so far? Okay. The next one says no more than 1 4. So what's okay for us? What's a yes for us? How many 4s is yes? You have 0 4s, and how many other 4s could you have? 1. So we want to do the 0 and the 1. So on the last one, we did just 0. The first one we did 1. Now we're going to do them both together. And are we going to add or multiply those together? Could I get both 0 4s and 1 4 in the same set? We're going to add them. So those are 2 different situations that I'm okay with this, and I'm okay with this, and they happen besides themselves. So I actually just did this, right? I just did these 2 exact probabilities above. This is the probability of rolling 0 of something. I don't care if it's 0 2s or 0 4s or 0 6s. 1 times 1 6 to the 0 times 5 6 to the 5th. That's the same thing as rolling anything 0 times. And then the probability of rolling something 1 time, whether it's a 3 or 4 or 5, it's the same thing as what we did above. 5 times 1 6 to the first, because I want to roll that one number 1 time, and then I want to roll anything but it 4 times. I'm going to put this straight in the calculator. I can do just like I did last time, 5 over 6 raised to the 5th, and then I'm going to add that to this. I can do that all in my calculator at the same time. parentheses 5 divided by 6, parentheses raised to the 5th, and then plus 5 times 1 divided by 6 raised to the 1st, which I don't need to write, and then times 5 divided by 6 raised to the 4th. I guess it's a pretty big percentage. That gives me about 80%. You guys doing okay so far? All right, can we do the last one? At least 1 6. What's okay with us? How many sixes is okay?
1, 2, 3, 4.
Good. 1, 2, 3, 4, 5. Now, even just writing 1, 2, 3, 4, 5, that felt like a lot, right? So do I want to write 5 separate probabilities? No, what could I do instead? What's the total? I don't think so. Did I hear it? No, 100%, which is 1 when we're just thinking about fractions. So we're gonna go 1 minus, and then could you find what the no is? The no is getting 0 sixes. So I'm just gonna take the very, oh, that's not at all what I wanted. Stop. Oh, no. We're imploding. Sorry, guys. No, which is 0, which means that I'm only gonna care about this part right here, which we've already done. 1 times 1 over 6 to the 0 power. The probability of rolling 6 0 times is gonna be 1 over 6. And then rolling anything but 6 5 times is gonna be 5 over 6 raised to the 5th. And then I can just put that in the calculator. So I'm basically doing 1 minus 5 divided by 6 raised to the 5th power, which is about 60%. We doing okay so far? Okay, that's really all I want to do today. I think that gives you enough to work on your homework. I will say number 3 is a little bit funky, so I want you to try number 3. And if I decide I don't want you to have done it, we'll talk about that on Wednesday, but I do want you to look at it and see if you can figure it out. But you definitely need to know how to do 1 and 2. Those could be on your quiz tomorrow. And then number 4 is what we just talked about.